Okay. So what I'm gonna do is I'm gonna run you through some trials we ran some time ago, a couple of weeks ago, as Letitia said, about the use of fast act in cold climatic conditions. My name is Dieter, and I'm Austrian actually. I'm a CBRN consultant for Timmerland already for a number of years, and those that have listened to some of the webinars, you've probably seen me before. So here we go. Letitia said about 45 minutes. It might even be a bit less. Let's see how it goes. So the content is mainly the definition. What do we mean by cold climatic conditions? Then the setup itself, and then the test itself, some conclusions, and just one slide on some other technical information about some other products. So at first, of course, it was the challenge to say, okay, how do you define cold climatic conditions? Of course, products have ranges. When you look at some other decon products from 0 degrees Celsius to minus 30, you find pretty much everything. And we really wanted to link it to an existing standard. So we looked at actually NATO, as NATO has pretty much standards for everything. How does NATO define cold? And NATO looks at the various categories, and starting from C0 all the way to C4. So now looking at also the testing facility where we ran the tests, and I come to that in a second. So we basically chose to be in the range of approximately minus 40, minus 45 degrees Celsius, which is the equivalent of C2. As you can imagine, running these kind of tests practically not only in a glove box, but in an actual chamber has its challenges itself. But we really wanted to see how Fast Act A behaves at these cold temperatures. Some of the equipment that we have, like the pressurized cylinders, do they still work at these kind of temperatures? So this is something that we actually wanted to test. And those that have worked with us in the past and still are, you know that we are very strong in providing testing data. So we always want to test something before we go out and claim certain things. So we chose the range of minus 37 to minus 46. And here you just have a longer explanation, definition of it, what the NATO standard actually says. So, and C2 applies to colder areas, which includes some countries, like, for instance, Norway, which just recently attended an event where we also presented these kind of results. So C2, that's where we are operating in. Now, as I said, minus 37 to minus 46. We picked a range because we had to see with the test setup if we could really keep it at all times in that particular range. I will show you in a second the tasting chamber when we have to open, to close it. Did this have an impact on the temperature inside the chamber? And just for information, I just put here also the Fahrenheit. So we are in the range of roughly 50 degrees minus 50 Fahrenheit. So where did we run the tests? Well, we had to identify a facility that provides us with various options. And this was a facility in Turkey. And we went there. And of course, the next challenge was also which kind of chemicals are we going to use? Because at minus 45, most of the chemicals are solid, but we wanted to test with liquid chemicals. So we looked at what is best what is available, what we can also use safely for these kind of tests, because of course we had to operate in an industrially used chamber, so we didn't want to run the risk of contaminating it. So we came up with a few chemicals that we used. So we had diluted acid, as you can see it here, sulfuric acid, and we also used DMMP, something that is used for decon trials, also as an industrial standard if you don't want to use any kind of agent. And we also used HCl because we needed it to produce some chlorine gas when mixing it with granulated bleach inside the chamber. Why did we need that? I will explain in a second. For the detection itself, we tried, and I can tell you we tried, but you will see some pictures later on. It was quite difficult at -45 because you are usually outside the range of any kind of electronic equipment. And so we tried also with the pH paper. As I said, bleach powder, we needed that one to produce chlorine gas and, of course, some miscellaneous items. So, as I said, the challenge was how do we gonna run these kind of tests? Can we run it in a smaller chamber? Do we need a bigger one, or do we really need to use a huge one? So we chose a chamber in which the operator, myself, could work inside. The glove box was not feasible, and the very big one was just not necessary for these kind of trials. So you see here the testing chamber, and of course there is, for those that are interested in more details than are presented here, you can always reach out to us for the full test report. You can reach out to Letitia. So, of course, you work inside the chamber at -45, which presents a challenge in itself, especially for the operator. Not so much that the body gets cold, but the hands, because of course you have to work with protective gloves. And at -45, that made it quite challenging. So this had a bit of an influence on the entire test setup, because you cannot spend too much time inside the chamber in itself. Also, what we did and attempted, of course, is trying to document everything. So we even installed a camera that is specifically designed for that inside this chamber, so that the operator, myself, I could work freely inside without having to think of recording or videoing what we're doing. Unfortunately, the camera also at -45 decided not to work. So what I had to do is then, as I wanted to record everything, I used my mobile phone. So now I can vouch for my mobile phone. It also works at these kind of temperatures, but of course you only use it for a couple of minutes in these kind of temperatures. You don't acclimatize that kind of equipment, the other stuff you do. So that's why some of the videos also that we're going to show to you, they were taken at -45 while running the tests with a mobile phone. So it's not the best quality, but at least it gives you a fair idea. Also, during this webinar, what we didn't want to do is just bombard you with some technical data, but we literally wanted to show you how we ran the tests, what we did, so that you have a kind of impression also from an operator's end user's kind of perspective, and a bit more insight into the test setup. As I mentioned before, what did we use? Interestingly enough, when you dilute certain acids with water, the melting or freezing point, depending on what you want to call it, goes down significantly. So that's what we did. And of course, we tested it. So we had some trial runs where we used the acid, the DMMP, inside the chamber to see whether it would stay liquid as it should, and of course it did. And here you also see fast-act, the lot number of the actual powder, fast-act powder that was used, and the various kind of acids. So also the granular chlorine with 90%. As I mentioned before, we also used the pressurized cylinder inside. So not only did we want to test the liquid component, meaning the decontamination, containment, neutralization of liquids, but as fast-act is the only dry decontamination powder that can also be safely used against vapors, we wanted to test that as well, which in itself poses a bit of a challenge because the powder itself you can bring in on a plastic tray, in a cup, but not the pressurized cylinder. So you have to bring in an entire pressurized cylinder. So we also had to test not only the powder in itself, but also the pressurized cylinder, if the pressurized cylinder would work at these kind of temperatures. Also, what we did at these kind of tests is we didn't just lower the temperature to minus 45 and then immediately ran the tests afterwards. But what we did is we put the equipment that we used for testing, and here mainly fast-act and all of its components, the pressurized cylinder, the powder, but also the other liquids, acid, and as a control liquid, we also put in water. We put that in way before. So for instance, the pressurized cylinder in total, prior the use inside the chamber, it was cooled down to minus 45 for more than 1 hour. And you could clearly tell, even when just doing the trial at first outside, that the hose that is attached to the pressurized cylinder was really stiff and very hard. So we really tried to have everything inside the chamber for a long time prior to the test. And as I said, minimum 40 minutes. And in the case of the cylinder, it was even more than 1 hour. This is just nothing special, just the general equipment that you kind of use in these kind of tests, pipettes, trays, bowls, all sorts of things in a scale, of course, to use a specific amount of fast-act. Also, because what we wanted to do is to see if the chemical reaction of the product is somehow altered at these kind of temperatures. Because one thing is you go inside and you use it without any kind of chemicals or simulants. You just use it and you say, well, you know, it's still a powder, but does it actually still work? Is the reaction slower? Is it delayed? Or does it work the same at minus 45 degrees Celsius as it does in normal kind of room temperatures? So this is really something that we wanted to see and to check. Now, looking at the powder, as I already said, which kind of test chamber at first to use, because those are not tests that you run every day. Would the chemicals stay liquid? I talked about that already. And of course, you look at the test objectives, what is possible also safely, especially then with the production of chlorine gas inside the chamber and these kind of things. So whatever you do, you have to test it beforehand. And of course, you try to detect. So we had one handheld device that is still in use that worked outside. And inside, you will see in a second whether it really worked or not. How to use the pressurized cylinder inside. And now you might say, well, what is he saying? Why is he, mentioning how to use it? Well, you spray it. Yes, you do. But if you release the powder What you don't want is that the powder is everywhere in the testing chamber, because that would then later on involve quite some cleaning operation. So we wanted to avoid that as well. To that end, we had a small kind of sort of glove box without gloves that we used inside the chamber to contain the powder when it's released with the cylinder. So those are all the small things that you have to consider when you run these kind of tests. As I mentioned before, as the chamber, the door, of course, had to be opened and closed, especially the operator, myself, I had to go in and out. So when the door opens and you close it again, does the temperature really go up again? So do we lose the cold air to the extent that then the operator inside has to wait for the trial to take place, or can you continue right away? And as I said, the pre-test of the cylinder. So those are just some screenshots of the control panel of the actual chamber. So one thing is you set the temperature to -45, but do you actually have -45? So on the left-hand side, you see the temperature that was set. And on the right-hand side with this kind of thermostat, you see the actual temperature. So we were operating in the range of -45, and everything was locked here. So we were more towards -46, so which is already the upper, so to speak, level of C2, already leaning towards C3, versus going C2 leaning towards C1. So we were really in the colder range all the time. Now, excuse me, we had the acid inside the chamber at first as well, because not only, of course, do you have these kind of data in research and peer-reviewed papers, but when you run these kind of trials, you want to really check beforehand, is it still liquid? And here is just a very short video where taking out the acid right away from the chamber, so you can see it was still liquid, so we were good to go. Because what we wanted to avoid is, of course, going inside and then finding some issues and problems, and we couldn't really run the trials as we wanted them to go. So also we tested the TMMP. So we put the TMMP inside. Is it actually still liquid? So we had it inside for 30 minutes. We took it out, and then we just checked if the chemical is actually still liquid in its liquid form. So that was all. We were good to go. And here you just see this kind of fume hood chamber that we also then used inside the test chamber when we ran the trials with the pressurized cylinder. Not the other trials where we were mixing fast act with the acid. This was done on the table without this chamber, this glove box. But then when we were going to release fast act and the pressurized cylinder, we had to contain it for reasons that I mentioned before, because there is one thing that you definitely don't want to do, and that is have the powder in every little corner of this testing chamber. So, of course, what we did is we had a specific amount of fast act, we had a specific amount of acid, we had a specific amount of DMMP. Of course, that's clear when you run these kind of trials. You need to establish the parameters. You need to know exactly which kind of amounts you are using. On the right-hand side, you see a screenshot of the camera. Also there, you see the cylinder already lying on the floor. You see the setup on the table with the different trays, the fast act, the aluminum plate with the DMMP. So everything was prearranged, pre-set up. However, this was the last that we got out of this camera, because a few minutes later, even prior starting the trial, the camera said goodbye to us, and I was then forced to somehow manage and document the stuff also inside. The biggest challenge, in all honesty, was at -45 to work with rubber gloves, take pictures, manipulate your telephone, and also run the trials. You had to be quite quick, because after 5 to 10 minutes, you had to get out, because your hands, it was just literally impossible just with rubber gloves. So here you see again, as I said, I tried to do all of that at -45 with my mobile phone, just to check all the liquids. Also, what we did is we put in water. So the same amount like we had acid, we also put in water just to see, obviously water would freeze, but just as a sort of check. So here you see the solid ice particles that were there. Then here you see the various trays. Here you see the acid is still liquid, even after 40 minutes, and so was the DMMP. Yeah. So just checking that everything basically was at its supposed to be. So and it's really I think more interesting to show you just some videos and pictures and some footage, rather than just presenting word-heavy slides. I think this makes it also a bit more interesting. Now, how did we test now the fast act at -45? Well, at first, is it still powder? So what does that mean? Of course, powder is powder. It's not going to become something else. But does it still behave the same way? We have a lot of experience working with fast act under normal ambient temperatures, but not at -45. So what happens with the powder if you let it sit at these kind of temperatures? Also, the humidity was a bit higher. So then does it still behave like a powder like it normally does? And I also have a video on that as well. So what does it do then when you put the powder onto the acid? How does it react? Is there a delay? Does it neutralize the acid right away? How does it work? And this is something that we wanted to try inside at these kind of temperatures. So now here I'm trying to do that, and as I said, I recorded it. Now the interesting part is I took the pH paper, and I was a bit puzzled, because the pH paper basically told me that it's nothing. So it's the pH paper didn't react at all. I didn't know that the pH paper at -45 degrees Celsius doesn't work at all. It doesn't work. So the same kind of pH strip, when we took it outside and it was a bit warmed up, then immediately it changed color. But inside here, it didn't work at all. So then you put the powder on the kind of chemicals. Fast act is still fast act, so it behaves like it should. It's in absolute powder form. So we could cover the surface, basically mimicking other decontamination trials that were done elsewhere, where we have long and elaborate test reports on this by the Spanish MOD. And here, then I put the fast act on the acid. And when I put it on the acid, I saw exactly what I wanted to see. And you see here those bubbles. It started immediately to react. It reacted immediately. So there was no delay, despite the fact that you see here the bubbles, it was -45. It reacted immediately. So, which was very good. And that's exactly what we wanted to see, to verify, and also to confirm. So, and then, like always, if you want to neutralize it, you maximize the contact between the fast act powder and the chemical to be neutralized. And in this case, this was the acid. So that worked very well. Now, this was the sulfuric acid, and on the other side was the DMMP. The DMMP, we basically also just wanted to see that FastAct behaves like it should. We didn't have the analytical means to quantify what was left on the surface like the Spanish MOD did with those DMMP tests, but it behaved exactly like it should have. Now here you see, like what I mentioned before, is nothing really exciting, but I was very surprised personally. Of course, you have a temperature range even for pH paper, but the pH paper inside didn't show me anything. And as soon as we took the same kind of pH paper, the same exact same strip, we took it outside, I put it in room temperature. Within minutes, it started to change color. And here you can see that we did have the acid, but at minus 45, it basically didn't work at all, which I found very interesting. We had then very similar issues also with the chlorine gas in the detector. So also, of course, how do you verify that it was neutralized? So basically, you take again the pH paper. You still have some wet spots in there that we used. If there are no wet spots, you just add a bit of water, and then you can easily, with another pH paper, see that FastAct neutralized. Here I just add a bit of water, so that FastAct neutralized the acid as it should. So that's the exact same result that we had many times in other trials and even demos when you say, okay, how does it work with acid? So FastAct reactivity, exactly the same at minus 45 compared to room temperatures, no difference. Detection is a complete different story. DMMP, the results were good in the sense of how FastAct reacted on the surface with the chemical, but we couldn't quantify the remaining DMMP due to the lack of analytical equipment. If interest is there, we could even repeat this kind of test settings at a later stage. Now, I just want to talk a bit about the pressurized cylinder in the chamber and the vapor stuff. Yeah. So when you look at the decontamination of vapors, it's a bit of a stepchild in the field of decontamination. Nobody really talks about it. It is not reflected in any kind of standards of NATO. NATO talks about liquids, but not about vapors. Now, when you look at the attacks, and I just took something here from Syria, for instance, you also have the source there. So you see the vapor threats. Yeah. So you see the vapor threats here because we have chlorine and GB sarin. So over 96% of the attacks were actually carried out with chemical substances that do most harm in vapor form. And when you look at decontamination methods, you will see that there is no other possibility of using a decontamination equipment, a liquid, a powder, safely to knock down vapors. With FastAct, you can. And before we move into the chamber, just some data. We have plenty of data. As I said, we are heavy on data, field trials and testings. So what does FastAct do when you use it against vapor threats? Here you have industrial chemicals in a set room, specific parameters, for instance, 28 cubic meter room. And here you have the relevant ppm before and after. So it works. Now, this is just something that I wanted to show you quickly. some of you might have seen this before. Those were some trials with GB. So here there is GB in a tent. So we put the GB in a tent. Of course, GB vaporizes quite quickly. So you can clearly see we have results on the detector. We used 3 different kind of detectors. The CAM, we used the AP4C and also the LCD33. In the back here already, you see the pressurized cylinders that then subsequently were used to knock down, to neutralize these kind of vapors. So you see here, about 1 kilogram of fast act was blown into this tent. It's a regular shower tent, actually, of a military unit. And then last step, again, I just quickly threw in those videos. Immediately after, again, you try, and you see fast act powder is still airborne. Can you detect anything? You cannot detect anything anymore. So it works. So it knocks down those vapors. And now, does it do that also when we go into a setting of minus 45 degrees Celsius? Now, how are we going to do this? This was a bit of a challenge because at first you need to have something to neutralize. And to that end, I ran some trials with this granular chlorine and acid to produce chlorine vapors. Of course, it's very difficult then to quantify it in the sense of that you're not producing too much, which unfortunately happened in the chamber. I come to that in a second. And also, we tried to detect it with one of the handheld detectors. We had a Chem Pro outside. It worked. And then inside was a bit of a different story. Yeah. So here we used it in here, and it worked. Then at the end, you see the trend line going up, and then also the detector going into an alarm mode. So here it worked. And then the detector also went into alarm. There is a bit of a delay with the Chem Pro. So that worked. But now, at first, we also had to check, does the cylinder even work? So first of all, you see here, I had to wear gloves because you don't want to touch metal when it's been in minus 45 for 40 minutes, unless you want to be glued to it. So we used the pressurized cylinder. So we put it inside for more than 40 minutes. We took it outside and we tried, and it worked. So now we know that the pressurized cylinder works at minus 45 degrees. Perfect. So at least that was important to know, because this is not only the powder in itself. Can we more or less produce the same kind of fast act cloud, so to speak, at minus 45? But it's also the hardware. Does also the pressurized cylinder work at minus 45? So both worked at minus 45. And then those tests, as I said, they were conducted in this small box. And in the small box, you see it here, I was producing this chlorine kind of gas. We had a camera. The camera didn't work anymore. And in order to contain the powder, I worked in this kind of enclosed chamber. So did it work? Yes, it did. We could not detect with the Chem Pro, which was not a big surprise because, of course, any kind of handheld detector at minus 45 would have great difficulties. The bio detector inside, that was myself. It was very unpleasant with the chlorine that I produced. As I said before, you cannot really quantify it when you add acid to those granular chlorine. And then, of course, I used the pressurized cylinder. I said, now I have to use it because otherwise I have to open the chamber and I have to get out. And I used it. And It worked very well. It worked in the sense of it worked physically. So I could release the powder with no problem at all. The cylinder worked like it always did. And it also knocked down the vapors, which was very good for me because I was inside without a protective mask. Here you just see the fine layer of fast act also on this granular chlorine, the yellow spot where I put the acid. Now here, what I'm doing is here now is I'm showing you this video. Again, as I mentioned before, it was a bit of a challenge. The video, the pressurized cylinder, the chlorine, all together. That's why sometimes the camera is not really on target, but most of the things you actually get to see. Here I tried to detect. It was already quite uncomfortable, so I had to hurry because the chlorine concentration was a bit high. Plus, I couldn't get any results, and the CamPro went into failure mode, so it didn't work. So I had to put it aside. And then I used the pressurized cylinder to knock down the vapors that were there. So yeah, so you see it worked very well. You can even dose it, so even low quantities. So the cylinder, and I worked a lot with the cylinders over the last years. The cylinder worked as it works also at ambient temperatures. And then, of course, the fast act settles and everything is covered. And luckily enough, also the chlorine vapors are gone. So it works at minus 45, also against vapors. Not only does it react like it should, but also physically the hardware works at minus 45. So those are just some pictures of the chamber at the end. There was a bit of powder in some areas of the chamber, but not too much. Had we released the pressurized cylinder inside the chamber without this sort of glove box, they would not have been too pleased because that would have meant that then they really have to clean it because also there is a lot of humidity inside. So it would have taken quite some time to clean. And like this, it was safer for the operator, myself, and also better than to clean. So conclusions, as I mentioned already, FastAct works in powder form and also in a pressurized cylinder. It neutralizes liquid chemical threats as it always does. It neutralizes chemical threats, and it also absorbs liquid chemical threats, like we had it with the DMMP. So this was the conclusion actually from these kind of tests. And what we wanted to do is actually show you that it's not only that we say, well, yes, it works, but we tried, we documented it, and there was a test report as well from the testing institute where we ran the tests. The testing institute that is certified also has a lot of NATO certifications, so everything is in place. So it does work. This is just some other products, and I just took the information from the web. What I had, I didn't really find too much in terms of testing. And when certain things are potentially used, the question is always, are they used with other chemicals? Do you really look at the reactions and reactivity as well? Some already say it's a slowed down. Others say it should not. But here are just some temperature ranges. GDS 2000, Kecha, they say minus 30. RSDL, the producer says 0 degrees. Water and soap, of course, depending on the kind of soap that you're using, but it's roughly around 0. Dahlgren says minus 20, and Techball Uvri, for instance, says minus 21. We went down to minus 45 without any issues, and I'm almost certain that it would have even worked at at lower temperatures, even at like C3, for instance. But to be quite honest with you, as the operator, the one doing it, I'm not sure how long I can stay inside at minus 50 degrees with rubber gloves. That was quite tricky. So that was, in summary, Letitia said about 45 minutes. Here we go. It was about 45 minutes. This was the summary of FastAct in cold conditions. So it's not only do we talk about storage, but also about the actual use. You have seen now how we used it, how we conducted the tests at a certified testing institute. Should you require more information, please feel free to reach out to us, to Letitia, or even through here you have the code on the screen. That's where you can find us. And now, Letitia, back to you in case there are any questions. Thank you very much.